Hi everyone, sorry for the delay there. We had a bit of a technical issue in the background. Welcome to the first live session of 2022. We're hoping to do a few of these over the year, educational pieces as we go through the season. So stay tuned, invite your friends to the group and we can all learn together. So tonight I'm joined by some industry experts. I'm going to let them introduce themselves in a sec. We're mostly going to focus on using lower flow temperatures in the systems that you guys work on every day. How making some changes now will not only help your customers to save energy and money on their bills, but also pave the way for the future, which is looking like it's going to be heat pump shaped. So intros from the guys here. Richard, do you want to kick off?
Yep. Hi, I'm Richard. I'm from Mid Wales Plumbing and Heating Supplies, and I generally specialise in controls and low flow temperature boilers. Next.
I'm there. Hi, my name's Kimbo. I run the Heating Academy up here or down here in Northampton, depending where you are. My small part in this is trying to make quite a complex subject, hydronics, simple enough for plumbers and installers to grasp. Bottom line is, if you start off with a bonfire or a nuclear reactor as your heat source, as soon as it's converted into water, that part of it stays the same no matter what. So if you can understand that, the rest of it's going to fall in place.
So I go?
Yeah,
go. Hi, I'm Rob Berridge. I'm one of the directors of Heat Engineer Software. Well, basically the first port of call of any kind of calculation is the heat loss calculation, and hopefully I can answer any questions as we move along with this. We'll see how we go.
Paul?
Good evening, everybody. My name's Paul Hull. I'm the Managing Director of the Commercia Group, and I'm the Campaign Director of the Gas Safe Superheroes, where we promote best practice industry and try and raise awareness and improve standards in our industry.
Great. And last but not least, Jo?
Hi, I'm Jo Alsop. I run a consumer advisory service, the Heating Hub. We provide one-to-one consultancy services, mini consultancy services for consumers, for households that either want to change their boiler, make their existing boiler more efficient, or transition to a renewable technology. And we prioritise efficiency and getting, for example, condensing gas boilers, condensing as much as possible and with the right control. So everything we're going to talk about here is our minimum standard, and that's how we advise our customers.
Great. Thanks, guys. And also thank you for giving up your time to do this session with us tonight. Please, those that are watching, please ask questions in the comments. We will try and get to them, and we'll sort of answer them as they go along if they're relevant to the conversation that's happening at the time. So to get started, let's talk about why everyone in the industry needs to start thinking about and implementing low temperatures in heating systems.
So do you want me to go?
My cue, is it?
How do?
Shall I go first?
Yeah.
Yeah, Rob, that would be great.
Okay. Well, as kind of said in the intro, it's absolutely imperative if you want to start getting accurate with heating systems. Is that a heat loss calculation has to be done first. There's just no way around it. You cannot calculate anything unless you have the first number to work from. It's as simple as that. We're kind of in a situation where lower flow temperatures are going to be mandated within the industry, and we don't have a choice with that. So it's going to be a question of whether we start learning now, or we wait until the 11th hour when we truly need to be doing it. And well, of course, I'm not going to say that we should do that. It'd be much, much better to have the knowledge anyway. So the whole point of working out heat loss within a building is how do we do it? At the stage that we've got at the moment, we are pretty much guessing. And we have a history in the industry at the moment, unfortunately, of oversizing plant to such an extreme that we've gone from old atmospheric boilers, old cast iron atmospheric boilers of 11 or 12 kilowatts, that kind of size, right the way up to some strange reason of buying the odd standard unit off the shelf of a 24 or even a 30 kilowatt unit for the same size of space. And yet we're also now moving to heat pumps, which the best-selling units in the country are between 6 and 8 kilowatts. So it is actually between 6 and 8 kilowatts is what the heat loss is within an average UK building. But so we clearly need to start thinking about how we're going to move to lower temperatures if we're going to start to move towards heat pumps. And so my view is that we now we should start to work out whether our systems are ready for heat pumps or ready for lower temperature systems at this stage. It doesn't really matter whether we're using gas boilers or heat pumps at this stage, but we do need to make sure that the systems are ready for those lower flow temperatures. And that's
it doesn't matter what the heat source is, does it?
Exactly that. So it's going to need larger radiators, possibly, but we'll get further into that conversation as we move on. But the heat loss calculation is absolutely the first and foremost thing that we need to be doing.
I think the main point for our customers is that, you know, we're about to see another rise in energy prices, and reducing the flow temperature improves the efficiency of the boiler and therefore reduces gas bills. And it's a really simple thing to do on a combi boiler, slightly more complicated on a system or heat only. So I think that's one of the main drivers. But also we're, you know, walking towards net zero, and gas boilers are with us, you know, inevitably for another 15 years. Actually, how can we get them running more efficiently? How can we reduce our carbon budget and our carbon footprint for our customers? And with some very low cost things, they don't actually need to move to a heat pump straight away. They can improve the efficiency of the gas boiler tomorrow with better set of controls, with just a bit of intelligence through the system and the design.
Yeah, brilliant. I wonder if, can one of you sort of talk about the differences between the two boiler types? So obviously it's easier for a combi, a little bit more complicated on a conventional boiler. Can you explain a bit about why?
Rick,
Kimbo?
you're on.
Do you want me to go? So basically, a combi boiler heats its water as it's used. So in that scenario, it's very easy to set different flow temperatures for domestic hot water as for space heating. So with a combi boiler, we can add load compensation controls, or we can just simply turn the boiler temperature down. If the system's semi-capable, or the temperature externally isn't too cold, we can actually turn the flow temperature down quite easily. Now, when we come over to system boilers, so some of the system and conventional boilers, some of the issues obviously we have is we've got stored domestic hot water as well, and that needs to be stored at 60 degrees Celsius to comply with the HSE. So what we struggle with there is obviously we can't turn our flow temperature of our boiler down to 50 degrees Celsius and then obviously turn it back up every time we want to heat hot water. That isn't going to happen with a consumer. They're going to leave it at 50 degrees and then we're going to have issues with stored hot water. So what we actually require in that situation is an element of intelligence behind the control system to reduce the flow temperature for the space heating, but then when you come to hot water recovery, it increases the flow temperature automatically to then recover the domestic hot water. So it's very easy to do with a combi boiler. So there's a lot of controls on the market, including manufacturer-owned controls and third-party controls that can actually lower the flow temperatures of the boilers that they're fitted to. But with the stored hot water aspect, at the moment, it's quite difficult to do unless you use manufacturers' controls. And there's a very small amount, a number of third-party controls at the moment that will do that over OpenTherm. So fingers crossed, as more people becoming conscious about lowering flow temperatures, more development will happen in the third-party controls to make that happen. Fingers crossed. Do you think that's all right, Kimbo? Any more to add to that, Kimbo?
Sounding good. I think I'll just try and share my screen here and try and explain what this lowering the flow temperature actually means. Because we talk about it as though everybody understands what happens and what the benefits are when we turn it down. So let's just see what happens when we do here. Share screen. Okay. Hopefully you can see something very green.
Right, hang on.
There we go.
go.
Okay, so if we look at the two axes here, we've got the x-axis, the across axis on the bottom, and this relates to temperature in degrees C. So this is the temperature of our water flowing in and out of the boiler here, and up here this side we've got our efficiency depending on the flow temperature. And I'll put a little red circle around 92 because in building regs it requires us to fit equipment or get the system going to a minimum of 92%. What I haven't been able to find out is whether that one's at 92% in its lifetime 92% for 50% of its time, or 92% for all of its time. But essentially what happens, this magic thing condensing starts at about 54 degrees. When the return temperature of the boiler goes below 54, we can start to save some of this energy. But unfortunately, it's not a switch. We don't get our return temperature down 56, it's not condensing, 55, it's not condensing, 54, and then ding, suddenly we're saving all this energy. Unfortunately, it doesn't work like that. If we go back to our old ideal classic type cast iron boiler, they had a flow temperature of somewhere around 80 degrees, and the return temperature was down here at around 70. And if we project this line up here and run it over, you can see that our old non-condensing boilers ran a number you've probably heard bandied about at about 86 degrees. Now, our condensing boilers weren't able to run at that temperature, because to get them to condense, we had to run everything at lower temperature. And so they reduced the temperature to somewhere around 75 degrees. Now, on a well set up boiler, if it's flowing at 75, our return temperature would be somewhere close to 20 degrees lower than that. So it would go out at 75, be used, heat in the house, and come back at 55. Sadly, that only happens when things are really set up well, which isn't often the case here. But if that was the case, if we take 20 from 75, we end up with 55. And you can see, hopefully, here, oh, hang on, let's get over. Let's go on to that one. There we go. You can see at 55 degrees, okay, realistically, we haven't achieved anything more than about 1% of efficiency. Okay, so the 92% that we're after, as you can see, we need to get our temperature much, much lower. Now, I think somewhere along the line, 𝗍𝗲𝗃 realised that if we set our flow temperatures at 75 to generate the hot water that we need for our cylinder, that our boilers could actually never condense. And so they recommend that we set our boilers to 70 degrees. So if we look at 70 degrees with a flow temperature, and we've managed to set everything up absolutely perfectly, which unfortunately very seldom happens, we'd have a return temperature of somewhere around 50 degrees. And you can see here, if we go to 50 degrees, our efficiency is now slowly creeping up to 90, but we're still actually not anywhere near our legal requirement. And we're nowhere near the 96s and 97s and 95s that we see stamped on the side of the box of the boiler. So realistically, if we're going to get our efficiencies to 92%, our return temperature needs to be somewhere in the mid 40s, somewhere around 45, 46 degrees, which means we need an absolute maximum of sort of 65, 66 degrees. And that's assuming that we can get our 20 DT. Now, if we're looking at some of the crazy claims that the manufacturers make at how efficient their boilers are, and lots of the guys I asked just assume that you put it on the wall and they're going to be that efficient because it says so on the side. You can see here, if we're going to get up to 96%, which is where we'd like to be, okay, our return temperature needs to be somewhere in the region of 34, 35 degrees. And if we add 20 onto that, that's where our 55 degrees comes from, which I gather is going to be our new flow temperature. So the low temperature heating is going to run between 55 maximum and 35 minimum, hopefully getting us somewhere way above the 92% that we are expected to find at the moment. I hope that helps explain what low temperature is all about. We always refer to flow temperature. Well, let's turn the flow temperature down. Yes, of course, but it's actually the knock-on effect of the return temperature that we're trying to achieve. Okay, so it's the return temperature that counts.
Can I just clarify something there, Kim? That's
yep,
possible.
You still want this thing on the screen?
Yeah. You want it on or off, mate?
No, leave it on, mate. Leave it on. That's fine.
Yeah.
That's absolutely fine. Just want to clarify to all the listeners here is that the system is not necessarily a 55-degree flow temperature. What is going to be mandated is a 50-degree mean water temperature. So the difference between your flow and your return being your mean water temperature within the radiator. That's what's going to be mandated. And so I think that's kind of, it might want to just try and make it clear to people of how that is. Yeah, if it's 55 degrees and you want a mean water temperature of 50, then it means that we've only got a DT of 10 because it'll be a 40-degree return, which will, as Kim says, will only give us somewhere on the looking at this graph there about 94% efficiency. Is that right?
Yeah.
Does that seem about right? Okay. Yeah.
So there's a question that's come in on the group actually that's relative to this. Somebody has asked, I don't know if you can see the whole thing, why can't you, for a system boiler, have flow temperatures of 55, then 60 degrees on a weekly for domestic hot water?
Well, the answer to that is we can, as long as the controls or whatever's in charge can raise the water temperature at least weekly. The problem is that never happens or gets it's not set by the customer, or the installer forgets to do it, or one way or the other, and then we end up in a situation where it stays at 55 all the time. And I've seen that happen so many times, and it's just one of those things. You've got to still protect public health at the end of the day, so that's paramount and that's primary above actual efficiency. But there are systems out there. I mean, I've got a heat pump at home, and it charges the domestic hot water to 50 all week, because if it was to charge it to literally 60, or if it was to thermally cleanse it every single day, then it would waste a massive amount of energy. Where actually my system, it's I'm happy, and I've made that conscious choice myself to do that. But ultimately, you need to protect the public that's out there. If they don't have the knowledge that you guys have, you need to play it safe at the end of the day, and that must come before any efficiencies made. Maybe Paul can clarify that. But
yeah, I was just going to add something there, Richard. Obviously, what our personal preferences are. In the standards, it says that stored water should be held at 60 degrees. Yeah, until that's changed, that is what stored water should be stored at. So obviously, you have it all week at 55. As I'm far aware that there isn't a device that will automatically turn your boiler up, and it should do prior hot water to 60. So the problem is, if you've got long runs in the house, you could then potentially have a leaking out of problems. Obviously, we really should be working on a 50 degrees within 1 minute at the tap. Yeah. So obviously, I've been in the industry for 35 years. Very rarely do I ever see the domestic hot water lagged under the floorboards.
It's not done, is it, mate?
We don't ever see it, do you? Yeah.
No, it's not done.
So we're losing thermal losses the whole length of the pipe work. So this is where the 60 degree come from, really. I mean, I know it's an old thing, but until it's changed, that's what we work to. We've got to work to the standards.
I was going to say, you do have to think about temperature drops as well, don't we? From the heating appliance out to the domestic hot water cylinder, because again, we don't insulate under the floorboards for whatever reason. I actually did in my house, so all the pipes are insulated through my house, right? But we don't do it. So like I always say, think, when you're doing system design, think about the whole design, isn't it? So pipes should be insulated under the floors. The same for radiator circuits as well. Pipes under the floors should be insulated to the heat emitter point. I know it's a lot more work, but ultimately we're getting temperature drops across the system. So if we are then designing systems at low temperature and we need 45 at the heat emitter, if you're not insulating under the floors and you're getting even a couple of degree temperature drop, you're then not achieving the mean water temperature at the radiators. So you have got to think about these things, The
biggest heat loss in anybody's house is the hot water system.
Yeah,
100%.
That's what people don't realise that. You can put as much insulation in your loft as you like. You can put triple glazing on your windows. If you've got a large house, your probably biggest heat loss in your house is the hot water system.
Not to get too bogged down in this, but I mean, for any listeners that do this, you might want to download or look up the HSE document. It's ACOP, so it's the approved code of practice L8, so Lima 8 is for Legionella protection. But there's one thing. I mean, I work a lot in the commercial industry, and I don't know if anybody does like commercial products, but if you're working on larger properties with secondary returns, certainly in the commercial sector, we have to have a return temperature as it gets back on the secondary return temperature as it gets back to the hot water cylinder of 55 degrees. Now that's really good practice if you're working in very large properties with low populace count, because that could cause problems down the line. So this is the reason for keeping that hot water much higher, and I'm sure that Kim and Richard are going to come on to 𝗵𝗲𝗺𝗃 circuits in a minute in order for us to have both systems, i.e. the very, very low flow temperatures for the heating circuits and high temperatures for the hot water circuits. I
just wanted to say one more point, actually. Joe and ourselves, we've been obviously campaigning for lower flow temperatures for a while, and one of the things we picked up very quickly was obviously the stored hot water aspect and making sure that safety came above actual reducing temperatures. So there was a recent campaign launched over Twitter by a big energy company, which actually compromised the hot water safety. So I just want to reiterate on that point. I actually had an email from the company, because I'm actually a customer of that company, and I actually had an email through to actually say there is some positive things. So apart taking that away from it, actually what you can save. So that I had an email to say that 200,000 customers had saved 5% on their energy bills by lowering their flow temperatures.
Wow!
So
Wow.
It is massive. So this is not something that we're talking about because it's just something to do. This is something that can actually make a massive difference to your customers' bills, especially in a time at the moment when energy costs are really, they're creeping up horribly. And, saving 5% over 200,000 customers, that's massive. And then they actually went on to say that actually 10%, I think it was 10% of their customer base actually save more. So there's big savings to make, by doing this. And, it's really important we start thinking about what we're doing and making sure we can actually do the best we can with the boilers and heating equipment that we've got. So,
implications. So I've got a combi boiler and radiators that are obviously sized appropriately to the room. Do I have to get new radiators that are bigger because the temperature through them is going to be lower, or is it a bit of a how long is a piece of string kind of question?
I think first of all, sadly, your radiators probably aren't sized correctly. Most radiators sizing is done not mathematically, but how sexy they look underneath the window. They need to be aesthetically pleasing, and we all understand that. I know a lot of customers in new houses really miffed by the fact they got a postage stamp radiator under perhaps a 4 or 5 foot window. It's just not what we're used to seeing. So the chances are that most of the radiators in your house are larger than they need to be, which means even when it's really, really cold outside, at say -3 or -4 degrees, those larger radiators will still generate the same heat that you need at a lower flow temperature. And that's only when it's at -4 outside, or -3, whatever your design temperature is. If your radiators are designed correctly, so when it's really cold outside, you've only just got radiators large enough, then when it's not cold outside, when it's not when it's not -4, which is most of the year, again, the radiators are oversized for the amount of energy that you actually need to keep your house warm. And that's where a benefit comes in of turning your temperature down. If you can get that to work automatically with weather comp or load compensation, and I mean, not all boilers have that, but most modern boilers have the facility for one or the other. If you get that retrofitted, even if your radiators are correctly sized, that's going to save you money as well. And if you put weather comp on rads that are too big, then of course you're going to save a bit more money. So it's all good. Our radiators are sized for the very worst that you're likely to see in your area, and that's like only a few days of the year. And if you think about it, if you look at the last time it was -2 or -3, the chances are for the majority of that time you're actually tucked under the quilt.
Absolutely.
Yeah, not too bothered. So I mean, yes, of course there are times when you're up and about when it's really cold outside, but percentage-wise, it's a very, very, very small percentage of the overall heating year. I mean, we have our boilers on about probably 8 months of the year, 7 months of the year for definite, and maybe not a lot in the spring and the autumn, but we still have them on. And what we don't want is to be wasting energy there because our temperatures are too high and our radiators are belching heat out, and so our controls, our TRVs and our room stats are constantly switching off. We've got too much energy going into the rooms, going into the property, and the only way we can do that is to sort of pull the plug on the boiler, which makes the boiler cycle, and that's not a good idea either. That gives you wear and tear on the boiler. So I think even if your house is correctly sized, turning the temperature down, it's still going to help for sure. If you can get it done, even better.
So the message that the installer can give to their homeowner is basically that I can do this on your combi boiler, which is a massive percentage of the market out there, I believe. the installers can do this on the customer's boiler, and it will literally make no difference to their comfort levels at all.
No.
Correct.
So that's a really great message that they can share with their customers to just massively help with that minimum 5% saving on their energy bills.
I think Joe's got the figures on the difference between combi boilers and heat only boilers, haven't you, Joe?
Yes, I did, and then it didn't quite work. But I feel like there's about 15 million combi boilers, and so there must be 7.5 million heat only boilers.
Okay.
So it's huge. It is huge. And I've turned the flow temperature down on my combi boiler. I've done a few bits, and I have upsized one radiator because my kitchen got a bit bigger. So I put a triple panel in, and what I wanted to do was test to see if I could run my heating system at 45 degrees with very little adjustment. So we've capped, within the boiler's parameters, we've capped the flow temperature at 50. So the dial now only goes up to 50. And I watch it because it's in my office and I'm nerdy. And you know, when it fires up, it will ramp up to 50, as Kimbo says, and then it stabilizes and it drops back down. But it is keeping the house warm at 50 degrees. And we've been through a few cold nights now. So I have a setback temperature at night. I think that's the other important thing to say, is that if people have their heating on for 2 hours in the morning and 2 hours in the evening, it might take a bit longer. Well, it will take a bit longer at a lower flow temperature to get warm. So that their heating patterns, they might need to have a bit of help with how they heat their home. But I now have it a setback temperature overnight and just a target temperature in the daytime. And the boiler, it still cycles because the minimum kilowatt output is probably too big, and I can't avoid that. But it is definitely running quite differently and staying warm.
Well, I can totally agree with that. I mean, my house, I've done the heat loss calculation, as you can imagine. I've gone into as much detail as I possibly can on mine, and it's literally just under 5 kilowatt. I live in an old Victorian mid-terrace property.
Mansion.
Two up, two down. Sorry, so what's that, Paul?
Mansion,
yeah. A two-bedroom mid-terrace mansion. Yes, of course. Yeah. I have refurbished it, but that was about 15 years ago before I know what I know now. So I would do it totally different now. Which these guys that are on this panel here today all know the scenario that I've gone through. But I've got this down to just under 5 kilowatt. Now that's a kind of fairly average house. I've converted the loft. I've put new windows in, and I've done some various insulation bits on the floors and the roof, but nothing massively drastic. I've still got 9-inch solid walls, etc., but just under 5 kilowatt. You know, I've got an intergas boiler in my property, which is Kim will let me know. It's about 3.5 kilowatt minimum modulation. So my boiler for 90% of the year is still just too oversized for what it is. So it's going to cycle. So I've used a simple load compensation controller in order, which Rich helped me out with, and I'm no electrician at all. I'm more of a hydronics designer, but it's unbelievable what I've done, and I've saved about 27-28% of my gas usage over the last sort of 5 years that I've been looking at it since I've upgraded and done all the works that I've done. So yeah, it's easily doable, and I think that it's easily doable now. And I think the average people, if we've got boilers that are running at 75, 9 times out of 10 by the time they got up to temperature, they're running at 75 flow temperature, probably 65 return. They're never going to condense, which we know most of them aren't. 80-something%, I think Joe was saying, something like that in a study that Joe did on this, that are not condensing. Then that condensing period that condensing benefit that you can get is, I think one of you guys is saying between 9 and 10%, something like that you can say. Now, if we go for gold and we can get 10% saving, can you imagine what 10% of the saving of the world of the nationwide gas consumption would be? I mean, forget anything to do with global warming and climate. We've just saved 10% just with very, very simple hydronic stuff. Never mind the rest of it. I think that's a wonderful move and a massive step forward.
Absolutely.
I think you've got to bear in mind as well. So one of the key things with hydronics. So if we take away everything else. If we just think about a boiler for a minute and it's what it's trying to do. So a boiler's trying to come on, it will ramp its output up and chuck that energy into a heating system. So if you balance a heating system to only allow so much energy to go into the heating system, balancing it is one of the key things you've got to do in heating design. Or if you're trying to turning flow temperatures down is one thing, but if we actually balance and get the flow rates into that heating system correct, even if the boiler's oversized, the boiler physically won't be able to throw in, say you balance a system to 10 kilowatts, for instance, and we have 10 kilowatts of flow rate going through the heating system, then that 30 kilowatt boiler, if it tries to put 30 kilowatts in, it just physically won't be able to get the energy into the water because there isn't enough flow rate going through its heat exchanger, and it will naturally ramp itself down to that kilowatt output. So even without range rating, balancing's a really, really key thing to do on a heating system to stop that excess energy and its ability to go into the circuit. Because if it has that ability to be able to flow into that heating circuit, then you can't undo that. If you chuck 30 kilowatts in, and that can't be dissipated by the radiators, that's going to come back onto the boiler's return, and it's going to cycle that boiler even more. So you're going to end up with it coming on full throttle, then it will cycle. And if you can try and mitigate that a bit by adjusting flow rates, turning flow temps down, adjusting flow rates, you're on a winner really. And then if you can go that extra mile as well and fit a load compensation control, then you really, really are on a winner. It's I recently involved in a project just up the road. Guy come in just for a smart control. It was a Drayton 𝗬𝗲𝗺𝗀𝗃, so I will plug you, Claire. So but he come in on, it was a Drayton 𝗬𝗬𝗃. It was a kit one. He had a combi boiler. It was a 𝗵𝗲𝗃𝗃 boiler, so there's not loads we could do with it. Apart from fitting,
except for change the boiler.
Yeah, except for change the boiler. But the problem was it was on-off switching, so we couldn't go on to load compensation. But what we could do is I fitted or I helped the installer upgrade it with an 𝗵𝗄𝗃 sensor. So actually, then we could weather comp the boiler. So even though it's still putting too much energy into the system when it comes on, at least when it comes on the warmer days outside, it's not coming on at such a high flow temperature, and it's actually firing up and then hitting that lower flow temperature, and then it's staying in condensing mode more often. So there's absolutely loads we can do, but there's just how far do you go? But these are easy sells to your customers. That's all I'll say is if you're going in and it hasn't got very good controls, and flow temperature set to 80 degrees and the system's unbalanced, those are all things you can do that will really help your customer save money.
I think one of the biggest problems what happened there, Richard, really going back historically, is when condensing boilers were released, there was no training, there was no understanding that actually what a condensing combination or system what it actually was. Hence why we had all the problems with frozen condensate back with the 𝗵𝗲𝗃𝗃 from the east. People didn't even realise that it was going to freeze, because some people thought the water come out there so hot it was never going to freeze, and there was actually and I think we let down, the manufacturers let down the industry really. There was no training at all, for the manufacturers. Sorry, I'm going to give everybody a bit of a hard time here. And then there was no real thought about controls. It's because like Kimbo's little favourite is, you walk past these boilers, we see all this great white smoke coming out about like there's a new pope, and everybody thought there was like that boiler's working really well. Well, no, mate, it's not. Yeah, right. But I still have engineers tell me the same.
Yeah.
Well, look at it, and they send me a thing on WhatsApp. Well, look at the boiler. Goes, well, mate, what's all that smoke coming out? It's working well. It's condensing, isn't it? Goes, well, no, it's not condensing, because all the energy is going straight out of the wall, mate. And it just, people's perceptions. And when you start thinking about controls and lowering the flow temperatures, they look at like you got two heads, Richard. They really do, yeah. Right? And it's just something like we need, and it's great that Drayton brought us on today and get the opportunity to talk about this. And so behind my dad's back, I did drop the temperature down. And they haven't noticed. I've got to confess, I have done it at home, and I actually turned one of the radiators upstairs. Nobody's noticed. I
did the same thing, mate. I dropped my mum and dad's flow. I dropped the flow temperature down their boiler to 55 because dad used to have it up at 70, and they didn't notice. And it wasn't for ages actually till I actually changed their boiler a few years ago, and we put an Intergas Eco RF in there. And yeah, they didn't notice. So I took their they had a main Eco combi boiler in there, and we took that out. And when I put the new one in, put it to 55, they didn't even notice. And this was before any of this kicked off. But obviously, if we've got the whole heat exchanger or the top of the heat exchanger at 55, and then everything below it's in condensing, do you know what I mean? So you got to, you know,
It must notice difference on the gas bills, though, surely, didn't they?
They thought it was just the boiler, to be honest, Paul.
Yeah,
you know, but you know,
I think there's another common misconception about what balancing is. I ask the guys often when they come here, you know, right, let's just get on to balancing. Right, what are we actually balancing to what? And it all goes quiet usually because it's a word we bandy about, and invariably what it now means is about getting the radiators hot. It's not about balancing it, because people say, all right, you know, I've got the systems up and running, the boiler's going, I've got to run around now and balance all the rads. And so we go through the, you know, how do you do it? Well, you know, we adjust this and you turn this one down and you open that one up a bit and all the rest of it and get them all hot. And then you throw something awkward in the conversation, like, well, if that one needs 1.2 kilowatts and that one needs 800 watts and that one needs 600 watts, how do you cater for getting the right amount of flow into any of these rads? Because like you were saying, if we put too much energy in, it's all wasted. And there's a big light bulb moment, and guys think, oh yeah, bloody hell, I've never thought about that. You know, we just get them hot, and that's because the way we were taught is by people that were taught by the guys that were taught with non-condensing boilers. And of course, nobody cared what the return temperature was then. And so when we, as apprentices, we've gone with our boss. You know, you see your first boiler going in, your boss runs round and licks his finger and sticks it on the rad. You get there all hot, that's fine. And that's just been handed down and handed down and handed down. And it's not until you say something really simple like that, guys think, look, hell, yeah, how do you do that? And of course, someone else comes up to the door, you put a DT, you know, put a clamp meter across the radiators.
Yeah.
And you think, come on, mate, let's get in the real life. You know, you try that for a few hours, you get one radiator somewhere close, you think, bugger that for a game of soldiers. I think you leave it. And the irony of it is, I think, is that the customers are happy with, because it's always been that way, they're happy with the bills that they're getting. Yeah. What I think the customers don't realise is if we all sharpened up a bit, all of our customers' bills would be lower. I mean, we're always going to get a little bit more efficiency when we put a new boiler on because the heat exchange.
Kimbo, they've got to be warm enough so they can dry their washing on, mate.
Well, I mean, that's what Joe's here for, educating the customer. I mean,
I still put my washing on already.
Yeah, my wife does. My wife will put like an eider down on a radiator that's barely warm, you know. And I say, look, that's what the tumble dryer's for. Obviously, a heat pump tumble dryer these days. But you know, that's what your tumble dryer's for. And that's a good thing. Just get to that heat pump tumble dryers. I bought one, you know, trying to do the right thing, leading by example. Bought a 𝗺𝗲𝗺𝗃, the most expensive tumble dryer on the planet. Richard recommended it to me. Thanks, mate.
It's all right.
Because it gets 5%.
700 quid, right, by the time it got here. My wife hates it. It takes about a week to dry a pillow slip. Yeah. And the other thing, you know, I'm like with IT, the other thing is the first thing you have to do is link it to the Wi-Fi. God only knows why, but there's an app, you download an app. I don't know whether you're supposed to switch it on the way home.
You struggle with that as well, I bet. Yeah.
I struggle with that. I got 3/4 of the way through and I just abandoned that. The whole world's gone mad with Wi-Fi, but technology. But yeah, I mean, the balancing thing is really, really, really important. And that's, you know, when we come on to pump pressures and stuff, most guys don't get that, you know. And you say, well, if you like, exactly as you were saying, Richard, if we've got more coming through from the boiler than we need, you know, that's the first. It's pointless putting all these fancy controls on, really. They're not going to do anything like what they should be able to do unless we balance the system up properly. And that's all hydronics, getting the right amount of hot water at the right place, at the right time, at the right temperature. And it's not difficult. We all know that. Once you understand it, it's not rocket science.
Is it worth saying that if everybody concentrates on getting the radiators the correct size for the lower flow temperature mandates that are coming in, and remember we're talking about mean water temperature. Now, yeah, obviously I'm going to talk about my own software, but I mean there's loads of software and loads of apps out there, etc., where you can size radiators, or you can
some of them are absolutely horrendous, mate.
Yeah, some of them are, and this is
I'm not going to name the manufacturer, obviously, but one of them is so far out, it's ridiculous.
Well, you've got to comply to EN 442, which is the standard for sizing radiators. But I mean, the domestic heating guide, the 𝗵𝗔 domestic heating guide, is superb for this, for getting that right. But you know, and we might as well get a plug in here. I mean, you know, I do training courses, and so does Kim do training courses, you know, on this. And so there's another guy as well, Adam Chapman from Heat Geek. He does courses on this. You know, we're all kind of in this together in a certain way to try and get these low flow temperatures correct, which I think is quite important. But getting the radiators right first of all. If you get those radiators, so they're going to be bigger radiators for a maximum flow temperature of your boilers. But I mean, if you're working on modulating boilers or open therm type controls or whatever it is that you're going to do, you might actually end up with a situation where you don't actually need any further downstream hydronic balancing. You might not need, for argument's sake, thermostatic radiator valves or anything like that, unless you're looking at managing air temperatures within different rooms. That might be the only time that you would ever really want to do it. But the bottom line is, from where I can see it, is if you get those low flow temperatures calculated from the radiator point, so your heat loss calculation, first of all, your radiator size, then to maximize your low flow temperatures. If you've got a modulating boiler, there shouldn't really be an issue from my perspective, as long as your system can accept like a priority hot water circuit, which we're going to, I think, talk about in a minute. To give you the two separate water temperatures that you need, and that means you can go as low as you want. I mean, that graph that Kim was just showing just a little while ago, yeah, if you can get your return temperature down to 30 degrees return, what a boon that would be. You know, my only issue now is that us as engineers, and I'm not sure how many we've got on the call here now, Claire, but a message going out to all the engineers on here: pressure your pump companies, because frankly, the pumps that are being supplied at the moment are just too big.
Too big.
They're too big, too powerful. I think the lowest one now goes down to about 200 odd litres an hour, something like that, which is around, what's that, Kim, about 5.5 kilowatts, something like that.
Yeah.
Right? I mean, that's an 20 DT.
Way too much. Yeah.
It's way too much for what we need. So, you know, if there's any pump companies listening, they need to be able to do this, or we need third-party controllers that can slow these things down a bit. You know, that's my 10p for a sec.
Question. One question that came in while you were talking about the different types of boilers. This is Denzel's question. What about more basic oil boilers, and how is it possible to use third-party controls to do lower flow temperatures on oil boilers?
That's rich, isn't it?
I don't think you can.
Very difficult to do two flow temperatures on all boilers because they aren't out there. I mean, Navian do an open therm oil boiler, but again, there aren't the open therm controls that can manage that effectively. So there needs to be a transition period. I mean, all boilers are very awkward anyway, because a lot of them are fixed output, which then presents its own problems, because obviously if you're fixing the output of that oil boiler for your -3, your -4, so say you're fixing it to 15 kilowatts for that, it's 15 kilowatts all year. It doesn't even modulate. So then how do you handle that then when your house only needs 5 kilowatts? So, you know, a lot of people or a lot of the top engineers with all boilers would always fit a buffer cylinder. But how many buffer cylinders I've come across in my career are I don't know, none. So, you know, and
cost as well there, Richard, isn't it?
Yeah, there is cost, but the problem is then you've got loss of efficiency and you've got wear and tear. I know all boilers are geared for wear and tear, but every time that thing fires up, it's not a temperature. You get the oil spraying on the back of the burner, and it's really not nice.
I mean, you're getting more two-stage burners on oil.
Yeah, but it's still not a nice process, is it? It's a really inefficient. If you compare an oil boiler to a gas boiler, it's a really the two boilers are really two different types of technology. And oil, I used to do a lot of oil. I did oil for 15 years of my heating career, and it's such a hard. I mean, there could be advances in it, but it's just such a hard technology to try and make better. But I mean, all boilers can still run at low temperatures. That's not a problem. No. But you need to then maybe think about how you're going to recover your hot water. Do you know what I mean? So if it might be by electrical means, if you were to run oil low flow temps, then you might have to have an immersion heater in the bottom of the cylinder that heats the cylinder up to do your pasteurization cycle or something like that. I don't know exactly, but it is possible. But oil has slightly different condensing zones as well to gas boilers. So
that's more of a question to oil manufacturers, really. Yeah,
it's more. You know, it's difficult. There just isn't the technology there. I don't know. Oil gets overlooked all the time, but there is quite a lot of it about. but good controls. So good controls though can make a big difference with all boilers. So having extended cycle rates and making sure they don't have the cycle rates that boilers do with controls, because gas boilers can handle sort of 6 cycles an hour and minimum on times of about a minute, where all boilers really you want them to run 3 cycles an hour. When I mean 3 cycles an hour, I mean 20-minute run times in an hour, okay? And then minimum on times of about 5 minutes with all boilers. You don't really want them running for a minute and then off, because that's really not healthy for them to do that. So controls can help. We struggle with the low flow temperatures with all, and yeah. The best you can do with oil, though, and I've done a lot of them, is with a multi-zoning product. So if you can stop the energy wastage with all boilers, because generally they'll overheat properties. So if you can try and stop that energy wastage in the rooms by having accurate room-to-room temperature control, that can help massively with all boiler bills. And I've actually had a couple of local people here save 40% just by multi-zoning. So there are things that can be done. That's my 2p on it, really. I don't know if anyone else got any thoughts on that, but
well, it brings you nicely quite into the heat pump scenario about the cycles scenario. That, I mean, ideally you don't want, you kind of want 1 cycle in every 24 hours, don't you? Ideally, if you can get it with a heat pump.
Yeah.
And so that's why I'm trying to push as much as I can. Not the fact that I care about the heat source. I don't care about the heat source. I calculate. That's all I care about. The bottom line is that we're going that way. We're going in that direction. We don't have a choice. So if we can start getting our systems ready for that, ideally we want that heat pump to run 23 out of 24 hours. If it's an air source heat pump for an hour of defrost time, if that's the case, that's the ideal from my perspective.
Some of the big problem with that, and Joe will verify this, is consumers don't know what to expect with a heat pump. So I had one guy today, okay, it was a classic. So rang me up. He's already got a multi-zone system with a gas boiler that he had, okay? So he's got a room-by-room system. He's just gone over to a heat pump, Joe, okay? Right? So now he's got the issue because the company who was MCS accredited, because I checked with him, they've not only put a 17 kilowatt heat pump in a 13 kilowatt heat pump heat loss calculation property. So they've already oversized the heat pump, but they've chucked a low loss header on it as well. So... Right, so it's gone on there. It hasn't gone on with a buffer. It's gone on with a low loss header, and then multi-zone control on the other side of the low loss header. No radiator changes, right? So he hasn't had any radiator changes in this property whatsoever. And he was asking me the best way to run it, and I was like, "You're going to have problems, mate." I was like, "You're going to have real cycling issues with the heat pump, and that's going to reduce your coefficient of performance of the heat pump, so it's not going to run as efficiently." And I said, your controls, unfortunately, in the heat pump scenario versus your gas boiler, where they would have worked really well with the gas boiler to save you energy because the gas boiler can handle cycling and things like that. They're now going to be the antichrist to the system, because at the end of the day, they're going to cause that heat pump to cycle, which is the complete opposite to what you're trying to do. So it's, goes to show that the consumer advice and the installer in that case, I mean, they've let this customer down massively. And,
quite a common story, though, Richard, isn't it?
Yeah.
Sadly so, but let Joe,
Well, yeah, we see a few, and they're quite consistent problems, like the one you've illustrated. Like, the buffer's too small, the heat pump's too big. It's not allowing a minimum runtime on the heat pump. There's not enough volume in the system, is there? And as you say, the microzoning. So I think it's just a real lack of knowledge and a sort of a rush to do it, isn't there? There's a rush to fit them without taking a step back and asking how they're different. But I think, understanding low temperature systems for gas boilers, it can really help to begin to understand low temperature systems for heat pumps. I know one of the things that a lot of the guys on our network come across, and you'd have come across, and Kimbo knows with the guys that he has, is that the ones that are out there advocating lower temperatures and low comp and weather comp, they're usually a sort of lone voice, aren't they? They're the only ones saying you should have a smaller boiler and a lower flow temperature. And I think
I haven't come across any companies yet, Joe, doing it.
No, and I think I think it makes for a difficult upsell often. So installers that have been doing this for many years actually meet a lot of barriers from the consumer, because they don't know that actually they're the one that is right, and the other two guys that have come through the door are wrong. They're saying, "I'll put a 30 kilowatt boiler in, and just that switch that you've got already, and away you go." So I think one of the things I was going to say was that I've got blogs on my website, and Richard has really good blogs on his website about why our condensing boilers are not condensing, how your boiler can run more efficiently, how do you lower the flow temperature, and why is it beneficial. We've tried to provide the education exercise that is completely missing for consumers and for a lot of installers through our website and through publicly available information. So if you do start to change your working practices and you're coming across resistance from consumers, you can refer them to our website, to Richard's website, and make that part of your sales pitch, actually, that you're progressive and doing it right. But I think, we've got a page on our website about lowering the flow temperature. It is the busiest page on my website at the moment. So there definitely is, thanks to said energy company, there's some momentum around this. About lowering the flow temperature. There's
funny, Joe.
education.
I'll tell you something very quickly, Joe. I actually had someone come onto my page about my priority domestic hot water blog I'd done on there.
Yeah.
Come from your website, okay, and asking me, oh well, this one guy's quoted a smaller boiler, and I've had these other two quotes, and this guy come from the heating hub, and he's talking about priority hot water, and the other two guys going to do S-plan, and he was like, oh, who's right? Because one guy's coming at, I think he said it was like 37 kilowatts, and he said this other guy's coming and he's quoting a 19 kilowatt system boiler, and it's miles smaller. And I said, well, he's done the heat loss calcs, he's done everything.
I'd have probably done the heat loss calcs.
There we go.
He's one of our customers.
There you go. Well, you've done the heat loss calcs. Everything's right. I said, what's the reluctance? And they're going, well, these other guys, they come highly recommend as well, but they've gone in with a 30 kilowatt boiler, and I'm like, well. Yeah,
I think it's really hard. It's hard for consumers to take what they see as a leap of faith. And even when they've come through us and we've given them a specification, we've done a heat loss, we've given them the report, we've given them, they've read our website, they're already completely warmed up to all the things that we've been talking about. They get a written report from me. And, most of the time, actually, they do go ahead with someone on our network. But occasionally they'll go, this guy online, he's like £1,000 cheaper. So I'm just
there's a lot of engineers that are listening to this, I'm sure, tonight. And I've spent 35 years on the tools, 40 years in the industry, last 5 years just doing design systems because I'm too old and fat and stupid now to get on the tools anymore. I can't do it. I need to be in the office now these days. But the bottom line is that I know as well as any engineer on here, any engineer listening, is that you're up against price or competition all the time. Trying to do the right thing is almost nigh impossible sometimes, but the mandates are coming. And so everybody's going to have to be doing it. And so getting ahead of the game now is a really, really good thing. And it doesn't have to cost the earth. Literally, I mean, I think we did a little study a little while ago of an average heating system of 6 or 7 radiators and upsizing those radiators. It's around. I think the top up that we looked at was something around 600 quid or something like that. If you're working on a system with a modulating boiler, for argument's sake, I mean, I know I'm probably going to get slated a little bit for this, but I've always used and always like the idea of utilising the existing one-pipe systems on circuits. No TRVs, nothing like that. Yes, of course, there's a radiator sizing issue that the flow temperature might be lower when it gets to the last radiator on the circuit, and it gets higher as it runs back to the first radiator on the circuit, but. No TRVs, no nothing. Simple lock shields on this unit with a modulating boiler. Very, very simple controls. Very, very simple hydronic system. I mean, you can't get much cheaper than that. You really can't. And it's going to work on the low temperatures, but it's got to be long, low, and slow. And I think that's the kind of message I kind of want to put out there. But you've got to get the calculation right of the rad sizing and the heat loss calcs before you can really get any of this correct, as far as I can see.
Yeah, it's a midpoint place as well for customers that want to be green. I mean, I've had people phone up and they're dead keen. They don't really understand it, And when
as they get into the Chelsea tractor going to Tesco's, Kim.
Yeah.
Yeah.
The quote's 15 grand, and they just can't afford, with or without Boris's 5 grand. They just can't afford it. And I definitely get it. I want an electric car. I can't afford one at the moment. So, it's a fact of life. But the radiators, I mean, I think really the government should be offering sort of something towards.
Steady on now, Kim, we're talking politics.
Yeah, I know. It's a much more effective way of spending your money because you're halfway there. I mean, the radiator size for 55/35 is about the same as it is for heat pumps. So it's certainly, if you can keep it like Joe. So we know that Joe's house is warm, a nice low flow temperature. So as long as
you have a big scarf on.
So yeah, that's to cover up all of the red dots, I think.
Sorry, Joe.
That's part of my style.
That's the halfway point. And so, like in 5 years' time, if a boiler packs up, she needs to get one. As long as the pipe works okay, she knows that the heat pump, other than that, is going to be absolutely fine. It's a done deal, isn't it? Whereas we know now people are handing over sort of £12,000-15,000, and it must be an almighty gamble.
Well, I think it's nuts, really, because I mean I'm all for the heat pump thing. I've got a ground source heat pump myself, right? So I'm all for the heat pump thing. I've had the heat pump years actually. Doesn't work very well actually, if truth be told, because what actually happened in my property, we put the heat pump in. It's 11 kilowatts, and then we over insulated the property, which then brought the heat loss down. And then now the heat pump cycles a lot. So
your heat pump's too big.
Yeah, well, that's the problem. And that's some of the problem you're going to face out there, actually, is what you're going to do is you're going to heat loss calculate the property now. You're going to put the heat pump in that's size for that. Then in the future, you're going to insulate your property, which then going to mean your heat pump's oversized. And then your heat pump that works okay now in coefficiency performance terms, as soon as you insulate your property, yes, you're going to use less energy, but damn, is that heat pump going to cycle?
The irony is almost hot, isn't it?
It's horrible, mate. And that's so, I mean, the thing that the government, if we're going to talk policy, the thing that the government's missing at the moment, we should really be insulating the properties first, get the heat loss down, and then put the correct size heat pump in for the property. With the gas boilers, though, what we can do is we can bring them down from 30 kilowatts because they've been thrown in, down, if you can range rate them, bring them right down to the correct heat loss after you've done your heat loss calcs. And then you're not throwing this extra energy into the system up front. Do you know what I mean? Because that's what it will do. If you've not got your flow rate set, it will just chuck that 30 kilowatts in for the sake of it. And we can stop that. So
what I did ask for was a cunning plan, actually, from the manufacturers. And I have asked the HHRC for this, that every boiler manufacturer that go out there, the boiler's set to its lowest modulation.
Yeah.
So then you would have to go into the parameters and turn it up. It's higher. So if it comes preset at the minimum, and then you have to go into the parameters and turn it up, and then that gets marked in the benchmark that you have done that. You have turned it up to X. Why have you done that? Because I've done a heat loss. Yeah, that's fine. Why can't they come out of the box set to the minimum?
Well, until the digital benchmark is fully rolled out and everybody and manufacturers have to get on board with it.
It's still not working properly, is it?
And that's years away, as we all know. It's years away, but that's the goal, isn't it?
Yeah. Why can't they come out minimum? Why have they got
same as the flow temps, though, Paul, isn't it? So flow temps coming out. I went to a Worcester the other day. It was 80 degrees flow temp, and that was out the box. I know I've heard Worcester Bosch have brought their flow temps down now. I think out the factory, but. It's the same as all manufacturers. Just bring the flow temps down, make it so you have to go through and commission it bit by bit. I know you're going to get
install the code in it to turn it up.
That's it. Yeah, I mean, manufacturers don't help themselves either, though, because what they do is they put all the, when you go through the commissioning on the Worcesters, for instance, right? You've got so many menus and pages of stuff where what they should do is group all the really important ones as the first ones and then have the more advanced parameters a bit further down, but they're just everywhere and it makes it really difficult for commissioning. I feel sorry for the guy. I've been on the tools myself. I feel sorry for the guys that are out there at the moment because it just seems everything's really hard for them to do and it shouldn't be that way. So it's and that's why I like open therm controls, because open therm controls, if we can get them all working, it's just two wires, two wires. It sorts itself out. Load compensation's great. I mean, I'm a big advocate of load and weather compensation, but load compensation's great because you can chuck it on most of the controls are fuzzy logic, and it will work it all out. So as long as you don't have the radiator oversized in the room you're referencing from, because if you do that, then obviously it references wrong for the rest of the house. But as long as that radiator is not oversized, then it will load comp the rest of the house lovely. Do you know what I mean? And just keep it simple, isn't it? But a big emphasis on flow rates, modulation controls, flow temps, system design. But like Rob said, you've got to start from a heat loss calc, then know what the rooms are losing, size your rads correctly, get the flows through the rads right, pump speed set right on the boiler, kilowatt output set right on the boiler, flow temp set, and then you're sort of there, and I had the big honour actually of working at Salford for the last couple of years, and when you see the differences these things can make to heat loss, the heat loss when you insulate, things like that, and you adjust the boilers up correctly, and you can see that difference happening. It's amazing, and loads you can do.
Should we do 2 minutes on how? I think people might be put off with priority hot water because it's a step into the unknown. It's a step into the dark. It sounds complicated. Nobody really understands what it means. I think it's got the wrong name to start with.
Hopefully you do, mate.
Well, priority hot water really isn't anything to do with the hot water, is it? It's
the water temperature,
the heating. Yeah. Fantastic hot water is just a side effect. It's a side bonus from it all. But the whole essence of priority hot water is to enable us to get these two flow temperatures, so that on your cylinder systems we can actually have nice low return temperatures to get our boilers in condensing mode. So I'm just gonna let me just see if we can do this. Share. There we go. Share.
What do you mean for time here, Kimbo?
Hey.
What do you mean we're out of time?
Oh, hang on a minute.
Claire's gone over. Claire's going like this.
But this is your priority hot water 10-way box. Okay, this is all you need wiring for your priority hot water. Okay, and this in fact is a little bit more complicated than it needs to as well, because what I've done here is I've left a 3-port valve in and converted it to a diverter. But essentially we only need 4 wires going from the airing cupboard down to the boiler. There's none of this S-plan, Y-plan, hundreds of wires, insulating tape, bits of chocolate block all hanging out of a unit on the wall. This is all you need. And here on the right, we've got our 2 wires that come from the cylinder sensor. So those 2 go in there and they disappear off down to the boiler. And essentially here, we've got neutral. Obviously, we need a neutral. This would usually be the brown if you were using some sort of diverter valve. If you modify or adjust a 3-port valve to make it into a diverter, you join the grey and white together, and that becomes your live. So here's our neutral, here's our live. That's essentially all we need going down to the boiler. The old orange wire, we don't use that at all. We just park it up. And of course, we need an earth down the bottom here. So realistically, the wiring on everything on priority hot water is both easier and better. I've yet to have someone say to me, but there is no but. Everything is better. It's more efficient. It's easier to fit. The whole thing should have been made sort of a requirement when condensing boilers came in. It's almost criminal that in the 21st century or 21st century we're still fitting S and Y plans, because our condensing boilers don't condense on them because they've got to run at too high flow temperature. So it's not difficult to do it. There's a couple of courses out there. Lots of manufacturers do it. No point asking your local rep. They probably won't know what the word even means. But I mean, most of our boilers, anything continental, everything on the continent's priority hot water. You can buy open, as Richard said, open therm control to retrofit. If you use retrofit controls, you don't even need to change the valves or anything. It's even easier. It's just done with a bit of wiring. As like Richard said, it's 2 wires. So it really, don't be put off by thinking it's complicated. It's an easy thing to do. If you want to have a dabble with it, if you speak to Richard, the beauty of speaking to Richard is he'll make sure you get all the right kit, and he'll give you circuit diagrams and everything to go with it. It's not like you're going down to plumb base and some guy there is going to give you all the wrong gear and you're left on your own trying to fathom it all out. So there is help out there. Once you've done your first one, you look at it when it works for the first time, you think, wow, that was a bit of an anticlimax. I thought that was going to be like an all-day struggle. Whereas in fact, it's cheaper, it's quicker, everything about it's better. That's it. That's my lecture over.
Wonderful.
That is brilliant, guys.
Well done, Kimbo.
Thank you ever so much for your time and a really interesting conversation. I hope everybody on Facebook has found it as interesting. Hopefully we'll be able to reconvene at some point in the future and do another session like this on some different subject. So thank you all for your time, and we'll end now. But thanks, guys, and have a nice evening.
Perfect.
Thank you for this opportunity.
Cheers, Claire.
Thanks. Bye.
Good night.
Take care, everyone.